All right, so 60 by 80 shop here, and I want to talk about the doors real quick. These are the panel type doors, and they run a jack shaft operator. Let me show you the problem with them. Can you see how that door is not all the way up? There's a issue you run into that I didn't realize until after we dealt with it. Now this has, there you have the jack shaft operator. It has a little chain, goes right over to it. And you can kind of see those cables up in there. Let me walk you over to this side where you can see it. This door suffers from the same disease of having these cables right up there. You can kind of see them. This cable runs all the way down from the bottom. You can't really see it back in there, but it runs, you can kind of see it back in there. That cable runs all the way up and wraps around that drum right up there. Now, the problem is that thing has tension on all this, but there's nothing to pull this door down when you push the close button. And if you have the door set up to go all the way up at the top, then the jack shaft will turn, the cable will bird nest instantly on both sides. Then you have this big disaster because it's off the runners. And you've got a horrible mess. Now, there are ways around that, what I've learned. Number one is if the tracks go on up the wall. Now, you can see this one right here, how the tracks go on up the wall, but there wasn't enough room to run it all the way up, so it's a panel short of opening all the way as well. If we ran it up high enough to work, it would go through the roof, and that's not acceptable either. So what we've got is a 10-foot tall door right here. Each of those panels is 2 feet. And forklift, thankfully, is just under 8. So when it's still a panel closed, here, I'll open it up and see it. You can see how it slides straight up the wall and still lacks a little bit of closing. But it has weight on those cables, so it's not a huge deal. You can see there how, well, it's not a full panel short, so it probably has 9 feet of opening there. And now when we close this button, you'll see how, this you gotta hold it. You hit the close button, it'll start falling there. And because it has weight on those cables, we've never had a problem with this door. However, that door there, when it's all the way up, is pretty flat. Just a little bit of that bottom panel is started in the curve. And when you have that problem, the cable will bird nest. Now, there's 2 solutions. Again, let me get back to those solutions. Number 1 solution is to run it on up the wall part of the way and then let it come back. So it's in essence, it looks like this, but the door's all the way open. Now, that is how this shop was supposed to be, but you can see that big piece of red iron is now painted white over there. That big, they call it a rafter in the drawings. But the rafter wouldn't allow that to work because you can see how close that track is over there. And I think we had about 3 feet, 4 feet of track that was supposed to go up. Well, that put all the track sticking out again through the roof when it showed up. So it wouldn't work. And these are CHI doors. I really like the door itself. I just think that the person that put all the junk together was, maybe just didn't have all the details or whatever, but it's a CHI door. I really like the door itself. This door is, I don't know, I'm guessing a couple inches thick, give or take. Each panel is, and it's insulated, and you can kind of see there. Now, we got it into a forklift there one time, so you have to overlook that part. But they're pretty easy to work with, and they're very modular. I can change that bottom panel, and I plan to someday. Just change that panel that's bad. Now, you've got to be careful pulling the bottom one because the bolts and things like that, the spring up there will kill you, so you got to detension the spring. But so solution 1 is to let it go on up the wall and then cut back. Again, we couldn't do that with the way this building was designed. Solution number 2 is to put a big spring on the back of the door that pushes against the door. And again, this is what I was told. I haven't put my eyes on one, nor have I tried to price one. But it's a big spring that sets up here that will push the door down when you push the button down. Again, more junk to fail, problems to have. And the solution we came up with is don't open the door all the way. Now, that's fine. If I end up with something that won't fit through that door, I can manually override it up here at the top. I can change that setting, let it go up, and then I can put a rope on this wheel setup right here, have somebody pull on it before we hit the close button, and it won't derail. So we've got a way to get around it and still use the full 16-foot in the event we need it. Now, that being said, I really do like a 16 tall door versus the shorter ones, because my camper is really getting close to that 14 foot. There's other things that get close, and sometimes I've had to work in and out of the door on stuff, and it's kind of tricky if you don't have any room above it to deal with. So I definitely, you know, consider going that 16 tall. Now, this door right here is 20 feet wide, and the reason we have a 20 foot wide door here is we're running a sawmill over here, and sometimes I need to carry, that has a 21 foot bed capability, or saw is 21 feet, and I can wiggle it through a 20 foot door opening. But if it was a 12 or 14 foot wide door, I'd be in real mess. I've had to wiggle them through, and it just takes an enormous amount of effort. So that being said, that's why this door is 20 feet wide. Do I think that's always necessary? No. It in this application it is. Now, I'll show you the doors at the other shop, which is also a 60 by 80, and this one's also 20 feet tall. That one's 20 feet tall, and that way you can kind of see what's going on with the mezzanine issue, you know, the mezzanine stuff. But the doors, while I'm still on the doors at the other shop are those thin little roll-up doors. They call them an overhead door, and they just wind up right up there at the top. And I really do not like them. They work good with this kind of operator because they're all stored right there, and they don't have that wind-up cable. But the door itself is not a very good door. So anyway, I just wanted to show this door right here, and kind of how that thing works. And let me see if it'll show. There, you can see how it kind of helps pull down on it as soon as you tap the button there. There we go. So anyway, some issues there with a jack shaft operator on a panel type door. Now, other things, you can see here how we have this block around the bottom and protection above it up to that. I think that's the second girder. I had them put that girder there, and it was supposed to be at 8 feet instead of where it landed, but they didn't do it, and we kind of dealt with it. Now, what there is 2 block around the bottom of this, and those are a 6-inch block because the girders on this building are 8 inches, and that didn't smash the insulation flat. And all I needed was something to let that wood go up and touch, and I wanted the block on the bottom so I could wash this out. If we have a water leak, if we want to hose out a spot or wash the floor, I'm not having that real nice plywood touching the ground and getting wet. And it doesn't have ground contact for it to, it'll just pull moisture right up through it. So that's that. Now you can see it allows us to set things against the wall without punching a hole in that insulation. I'll show you at the other shop. I did not do that, and I'll show you the problems with that. Now, for mezzanine, this mezzanine goes all the way across the shop in the 60-foot dimension. This shop is 60 feet this way, 80 feet deep. And then the last 25 feet or so is this mezzanine area. And I want to show you this because this has worked out really good. Again, we access it with forklifts on the top. And this is set up in a forestry application, and so wood is what we used here. Now, if I was building in my other shop, this would most likely be steel because it just looked good here, and we had the capability, and it didn't cost a thing to mill these big timbers. And those are 12 by 12 poplar timbers, and we cantilevered them. And I really like the cantilever because it gives us more mezzanine area at the top, as well as more room down here on the bottom that we don't lose. So in essence, we're gaining 4 feet for free. And so we have all of this area down here. We can walk in, we can set stuff, whatever, and then we still have 4 more feet up the top that we can set stuff on. And if that was steel, big I-beams, you can still set stuff on with the forklift without having any issues. These 12 by 12 poplar timbers are crazy heavy, and I don't run into any problems with them either. And they're sitting on a 16 by 16 back there, so you can kind of see how some of that looks. But there we go, and there's some of the big timbers back in there. But anyway, that's kind of some of the things that we did here that may be helpful. I'm going to walk over here next and let us take a peek at the heat. All right, so here is the heat for the system, for the floor. Now, this was the very first one of these I ever did. Several things that changed about it. Number one, when you, this is just a water heater. It's a 100-gallon water heater. The downside to this is it runs all the time, and it is run off gas. It runs, and you hear that whistle. It's something in the orifice or something there makes it whistle, but it runs all the time, and It was an old water heater. It's one we had, and I just use it so it wouldn't go to waste. I think I'm going to change it out for a boiler that has hot water, domestic hot water built in it, and I'll show you one of those when we get over to another building. So, but this is our system here. This upper manifold runs the outside apron heat, so that way we don't have to put salt on the concrete out there and then track that junk into the shop. So this, now it's not turned on right now, we've got it turned off. I just haven't got it all up and going yet. And this heater doesn't, I don't think it has enough capacity to heat that as well. We had it all figured up, and place up north, Connecticut or New Hampshire or something, I can't think of the name of the place right now, but they figured out and said that would work. It's not quite enough to melt the ice outside and keep that building warm when it's cold outside. So this manifold here heats everything under the mezzanine. It heats that classroom or saw shop and this mechanical room, and you can see how it goes down in the floor. Now that one, we did not put any protection around those pipes. I've never had a problem with them, but it leaves an ugly thing. This one is the way I like to do it. I like to put a pipe up through it, and those go outside, so I had to, that's basically a conduit to the outside. It makes a nice finishing job. It also keeps it from expanding and contracting right there at the concrete and potentially cracking, from what I understand on reading. I never had the problem. However, I don't like that, because if you have a piece of metal on the floor and it slides across the floor, it could shear that off and make it leak, and it just doesn't look as clean. That was tied very carefully, and it still ended up looking goofy. So not very tickled with that. Again, I would recommend a boiler with a hot water, domestic hot water section in it. I'll show one of those to you as well. Now, this is the in-floor heat for the shop, and each one of these tubes is 300 feet long. It's 1/2 inch. That's what they recommend. Has to be oxygen barrier. It is very inexpensive to buy this stuff. Good manifolds are not very expensive either. However, when you pour the concrete, make sure that your manifold kit comes with these nuts and ferrules. We've ordered some off Amazon that did not include the nuts and ferrules, and that is a major holdup when you're trying to pressurize it for concrete. So be sure that it comes with these little nuts and ferrules that go down inside that pipe, and it'll have I think it has an insert, a ferrule, and a ring, if I remember right. Don't quote me on that part though. So be sure it has that stuff. And this one, I couldn't get a manifold that had 12 in it, and so I end up having to get, it's 7 and 5. So they just couldn't get them quick, had to get it done. I was trying to get the concrete poured and everything. So over here you can see how this runs up through the pipes as well and just goes right into this floor. I really like that system a lot better. Just looks a lot neater and cleaner. Another thing, this tank right here is wrong. It needs to have the water in the top of it and the air diaphragm in the bottom to get the air out of it. So this is a bad system. It's really hard to bleed. So I'm going to change that too whenever I do the boiler. The other system we did, it's correct. Very easy to bleed. Also, this is a 100% antifreeze system because I'm running the outside apron area. This has no water. It's 100% antifreeze, and that is stupid expensive, but that's what I needed for the outside stuff. Now, hindsight, I would probably do just a separate heater for the outside, running the 100% antifreeze solution, and in a shop that I was at all the time, I would run water inside it and have a secondary heat source just to make sure it didn't freeze. So that would save an enormous pile of money buying that antifreeze. It is ridiculously expensive. Overall expense, this is not a super expensive heat source. Couple, $3-4 grand for a good boiler combo. The pumps aren't very expensive at all. Those are a couple $100 a piece. The tubing is very inexpensive, and in all honesty, you don't have to do it all up front. You can shove the tubing in the ground, buy the manifold so you can pressure test, and I built a little 1 inch. I think it's one. No, it's not. It's bigger than 1 inch. Anyway, it goes in here. I'm trying to think if it is bigger. I don't know. Don't quote me on that either. I built a piece here that will let me put a Schrader valve and a gauge in it, and that way I can test these when I'm pouring concrete. Just a Schrader valve, like a tire valve. You can get them. They have 1/8 inch think they're 1/8 inch pipe on one side, and then I put a T with the air valve on the other side, and just charge it with air compressor, and then keep an eye on it while you're pouring concrete. That way if a tube bursts, you're good to go. I keep a spare shark bite connector in this size at the job. That way when we're pouring, if there's a problem, we can dig down, find the air bubbles, dig to it, cut it with the little cutters, put the shark bite connector back in it. So anyway, that kind of breaks down the heat. This one, again, the first one I ever did, it works okay. Still needs some fine tuning to get it right. And this one, it doesn't have any connection to any pressure source anywhere. It is completely atmospheric vented. This is a fill pipe here to get a lot of so we can get the air out of it and have a little head volume in it. And this is another spot we can do that same thing with air, so that it just seemed to work better if air had somewhere to go. Over here, it just feeds out of this T down to both sides, to the outside and to the mezzanine. Again, very simple setup. Again, would make some adjustments, especially with this guy right here and that heater. It runs all the time. It doesn't have good heat transfer to the fluid because it's running all the time, so it's not really designed for that. The on-demand boiler that I'll show you is definitely a much better setup and works really, really good. So anyway, there's the heat. Another quick thing, talking about apron. This apron has the ability to be heated. It's not turned on right now. I do not have an apron at my shop at the farm, and it leads into a dirt road, and you cannot keep the floor clean. It's horrible. This right here, I really like it because when we sweep the floor and come out here with a blower and just blow all the sawdust, the dust, everything off, and I don't track it in the shop. Now, this shop is not made to be show place clean, but at the same time, it's kind of nice not to be tracking mud and crud in there just because it's muddy outside and it gets dripping all over you and everything else. Oh, one more thing, speaking of drips. The amazing thing about this floor is if you spill water on it, like right here, this was a very wet spot 20 minutes ago. And you can see by the size of my foot, it is almost gone. It will evaporate very quickly, which also improves a lot of safety issues. You don't have a big safety problem with the floor in wet. This floor is polished slick and has sealant on it. When it gets wet, it's quite slick. You can see right there was another pile of water. You can kind of see the outline of it there, how it's all, excuse me, already shrunk in size greatly just in a short period of time, because it'll just evaporate the water off of it. That floor is very nice and warm to the touch right now. Another thing, it's low 30s today, and when we shut this door, in 10 or 15 minutes the shop will be warm. It has an excellent recovery time. It is very, very impressive on the amount of time it takes for the building to heat back up because of this huge thermal mass. We're not heating the air, we're heating this concrete that then radiates and fills the air back with heat, instead of just blowing around a bunch of hot air that as soon as it runs out, then you got to fill this whole space back up with blown in hot air. So I really, really like those things about this heat. And I'll show you how we did this at another building at the church with a cassette type AC and heat system that is very cost effective to deal with and very user friendly. So anyway, that's kind of what we have for today, and I'll bring you back when we get to the other shops. Alrighty, here is another 60 by 80 20-foot tall eave height shop. Built this shop right at 20 years ago. So it's due a set of roof screws in it. Every 20 years you have to put new screws in it for the washers. But anyway, that's where that is. I'm going to show you something about the doors and the apron though. Right there's our 4th gen mega cab that's stretched, linked, bobbed, and narrowed. It's got 10 inches narrower axle Mosier shafts in it. It's got full 4-link with panhard bar. We just got a flurry on the forecast there last night. And man, oh man, it wasn't supposed to rain or snow or anything. But anyway, there's a panhard bar. The link bars go way up through there. It's 4-link with panhard, airbagged, and then bobbed right off on the back. But anyway, body panels, bedsides match the cab. But anyway, that's enough about that. But here is the deal with the apron. The one at the other building I showed you has a apron in front of the concrete and has heat in it. Very important for that location because it is north facing, and I didn't dream facing direction made so much difference. This is south facing and it melts off in no time. The back of this shop will have snow in front of it for weeks, and this will usually melt off in a day or so, just because it reflects all that light back down and melts it off. Another thing about this, you can tell it tracks mud in like crazy. We end up with driving down the gravel road, all this dirt here, I mean the gravel, dirt gets in it and it tracks in the building, and it's just an absolute mess. So that's a little bit about the apron here. This was covered 2 inches of light flurries this morning, and it's already melted off. So it's still not even to freezing yet. But these are the doors that came with this shop, and you can hear that thing, how noisy it is. When it's windy, oh my goodness, it just beats and bangs like crazy. Also, it doesn't seal well at all at the top. I don't know if you can see that huge air gap. The problem is you can't move it closer when it's closed because this coils up on a drum, and if you get it any closer, then the bottom of the door rubs. The drum just keeps getting bigger and bigger and bigger as the door goes up. And you have this huge 3-inch air gap at the top that is impossible to seal. And it doesn't seal well back through there. You can see there's huge bit of gap in that. And it's horrible sealing down here at the bottom. Mice and snakes and anything else can go right through that. So very unimpressed by these flimsy doors, and they are just sheet metal thick with zero insulation in them. And I'll show you the inside of them here in just a moment. Okay, we're inside the building here. I want to talk for a minute about these flimsy doors. They are extremely frustrating. They bounce. You can hear this inside the building. With a wind gust, they just sit there and flop and carry on. Very irritating. Also, the lights, these are metal halide lights. I really like the LED. They're in the other shop. I'll show you them. These are, in 20 years, I've changed light bulbs once already. This is a second set of bulbs. I've already got one out again. Of course, it's right where I work here at the lift most. I guess I wore it out. But anyway, but you can see these jack shafts, how they're set up with that operator over there. I haven't got the operator mount on that one because that operator is terribly slow when it's not hooked to power, and I haven't got to the power yet. You'd think in 20 years I'd got to that, but I have not yet. But anyway, you can also see the trim on these doors. It doesn't stay put well. It keeps falling off, and don't like it. The sealing is horrible. You can't get any seal in there, and you kind of see up there at the top, I think. Yeah, you can see the reflection up here on the top. That's from that 3-inch gap at the door I showed you from the outside. So if you're wanting to stick with a jack shaft operator like that, this is about the only door I'd recommend going with it, unless it was one that was going straight up and down like the one at the mill with no turn back in it, because this does not have those little springs to bird nest whenever there's slack in it. And that's the problem. When it doesn't instantly start down, that motor keeps going down, and it'll bird nest in just a moment. Real quick about the length, this is 20 tall, 60 wide, 80 long. The reason I did that, in a previous shop that I worked in right out of diesel school, we had one that was 70 deep, and we couldn't get long trucks in there and shut the doors on them. You could get a shorter tractor and a log trailer in there, and it would bulge the door in the back, just barely shut it front, and you'd have to crawl under the trailer all day long working around it, or if you're working in a different bay, it was an absolute nightmare. So when I ordered this building, that was another reason I went with 80, so I could pull a truck in and shut the doors on it, work on it, because it's real aggravating to have a trailer you need air diagnosed or light problems, and you have to leave the tractor outside because it's 20 degrees, and then you've lost your air supply and your light supply, power supply. So I really like to be able just to have the whole thing inside, shut the doors on it, forget about it. And it's nice if you're going out the next day and you want it not have snow or ice all over it. It's all in the dry, you just pull it out and go. So anyway, that's why it's 80 long. Trying to think anything else. The insulation, yes, I want to talk about that. You can see here these damages from insulation. This is insulation that came, it's 4 inches thick on the wall, 6 on the ceiling, and is not very durable. It really needs something to protect. You can see here from just this chain hitting it, it really degrades quickly. And you'll see at the mill how we put the block on the bottom and these doors, again back to the block, and the reason to wash it. I can't wash out this shop very easy because all that stuff down there gets wet, and if all that gets wet, it's a nightmare. And by having those block at the bottom, you can wet it, wash out the bay, whatever, and be good. I also put a floor drain in that one up there so that I could have one place to wash something. If it's cold, nasty, and I just want to get the salt off something, I can pull it in and everything's not frozen, and I can wash it in the dark if I have to. Here I did not put that in here, and I kind of regret not putting a wash bay in. Just a floor drain so I can wash something in the dry. Another thing is, back to the washing, is this door, the way these corrugations are, it holds dirt like crazy. That other door is flat and smooth. It doesn't hold this dirt like this one. And this is a real pain to wash. You have to have a man lift to get up there and scrub it all down with an RV brush and try to wash it, and you got all the water all over everything in here. That's why it's filthy. It doesn't get washed, and it looks horrible. And you rub up against it trying to squeeze between two machines, and you got black stripes all over you. So these doors would probably be great in a storage building facility where you're just storing a machine and you're not trying to seal it off from the elements, because it's a lot of room in there for problems and for air to get around, rodents, mice, things, snakes, but I mean, it's just anything can crawl through that. So if you're just trying to store something and keep it out of the sun and light and the rain off of it, I think to be fine. Put them in a heated building, absolutely not. Really wouldn't recommend doing that. So I do like those insulated panel doors, but the jack shaft just doesn't work good on those panel type doors. It really needs to have a trolley style system that's set back here, or let the door go way up the wall, which has been kind of complicated. Another problem here, sorry about the mess over here, but the way that this building seals is very unacceptable. You can see how the mice will come through that wall, in again, not even around a door. They'll come through the gaps in the sheet metal, and I don't know how they do it, don't know where they come from, but they will dig their way out of those walls, and really irritating. So another really good reason to have that block, and then the protection on the inside. So there's that. Another thing I want to talk about real quick is out here, is I try to put it in the end walls, the doors in the end walls, so the drip doesn't get on me when I'm going in and out of the building, and I don't have to run a gutter. You can see all the trees we have around here, and again, it doesn't matter. It seems like you're miles away, they'll still get in those gutters. But I don't run gutters because I run number 3 stone down here along the bottom with drain tile in the bottom, and it evacuates the water very quickly. You can't really see it with the snow on it, but water just drips off of that, and it drips forever. It'll drip for hours, even just with a heavy frost. It'll drip a long time. You can hear it dripping down through there. But I really like that. And again, if I had to put doors in a sidewall, I would look at doing a single slope roof design with a drip to the back. I was really thinking about building a building there in the back. I've got too much stuff sitting outside right now. Aggravates when good things are getting wet and sun beating on them. But on that, if I put, it will probably be long ways and with bays going back, and I would want a single slope roof there with it all sloping to the back. That way there's no drip and no need for a gutter. Just, man, a gutter 20 feet up in the air is it's an obstacle to deal with. I'm not a fan of heights, and going through 80 linear feet on each side of a building to clean a gutter 20 feet in the air is 0 on a fun meter. So anyway, all right, here's a shot of the LED lights that are in the shop here at the mill, and you can see they are pretty impressive. Another thing I didn't mention about those metal halide lights, if the power flickers, or if you turn them off and then you realize, hey, I gotta go back in and get something, they don't they take about a half hour to 45 minutes to come back on. First time it doesn't take that long to get them on, but if they're hot, they have to cool down in it, then warm back up. And but these, you can instantly have light again, and I really like that about the LED. Now I do have one right there that's giving me a little problem. Not sure if it's just in the fixture or something, don't know what's going on, but anyway, that light has been in there for I think 3 or 4 years now, and really do like them. Of course, you can never have enough. I'd probably put a few more in just to the edges get a little, you know, they're not as good as the centers, but anyway, that's that. But here's another shot of the wood stuff down the sides and the block along the bottom. And this bay right here is the one that is let's see, let me bring you over here. There is the this is the smaller of the doors. This is a 14 by 16, and that one's a 16 tall, 20 wide. This one's 14 wide, 16 tall. And this is the bay that has the wash rack, and then in front of it I mapped out for the heat a area to put a lift. I went home, measured the lift that I had at the house at the time, and measured the basic footprint, expanded a little in every direction so I wouldn't hit it with a drill, and marked it off, marked it in the plans, so that way we have in the blueprint we have the floor detail and where that is, so that if we need to drill in it, all we got to do is dig that up and measure it out. So anyway, that's kind of how that works. Here's the little man door, and we got water. Nothing is completely finished here. We still got a lot of finishing up things to do here, but you can kind of see how that block gives you a really, so you can see how they're 2 blocks high. And the front wall, where, let me make another point there too. On the front, it's tricky to trim out for a door because the metal doesn't work out right. So on this one, I brought the metal up a little higher. I still need to put trim and go down that corner for this piece, but these have 8-inch block, and they go all the way to the outside of the building, because you can see how that trim, that gray piece along the bottom, or kind of brown, that little piece that the metal sets on, it goes down past the pad a little bit. Let me show you what that looks like down here. So when you have a door, this is a side exit door, you have to build a ramp up into it. And I'll get down here, hopefully you can see that. Kind of makes it tricky. So it's probably 2.5 or 3 inches, give or take. I'm going off estimating there. So that's a little tricky deal there. So and here you can kind of see this drip. It's dripping right now. And this door, you walk out that door, you get dripped all over because it's a sidewall with no gutter. And again, just wasn't really, I do have gutter for here because there are absolutely no trees around, but haven't been real motivated to get them put on because they're just aggravating. But so anyway, I want to mention that about the door. So on the front of the building, we went all the way across and put the let's walk down here. On the front of the building, we flared the concrete up. Well, that's kind of slippery. Kind of flared the concrete up right there to meet the door, and with the block there, we don't have the issue of what to do with the siding at that point, and kind of did all the doors down through there the same way. Sorry about all the junk piled here in the way, but anyway, you can kind of see we have those done, and it still all needs trimmed. But anyway, just a quick idea of what that looks like. And then here, listen to this door, how solid that is. Remember when we were tapping on that other door, my goodness, it's just a mess. That is a very solid feeling door, and I really impressed with the panels, just not with how they're set up. So you can see they stay nice and clean on the inside. The hinges might get a little bit on them, but dust wise, but and these stiffeners, a 14-foot wide door does not have all the stiffeners on. You can see it's nice and clean and thin, but the 20-foot wide door does have all these stiffeners in it, and they'll accumulate a little dust on them. But anyway, just a couple things there about the doors. All right, there is the outside unit for the whatever we call that, the cassette type units, AC and heat, or heat pump stuff, and it goes right up through, the line sets go right up through there. Again, this building is 50 by 100. I've already locked that door, and it's 12-foot wall height, and it's set up for a church fellowship building. So but I want to show you how the heat is done in here. It turned out looking really neat, and does a great job. So walk around here. I guess I locked that one too. so here are the cassette heads right here. You can hear that thing barely running. Those little flaps move. Try to hold this still so you can see a little flap move. That lets the air direct all around. Hope you can see that. Yeah, you can kind of see it. All right, so there's 5 of those. Each of them have a separate thermometer, thermostats. I'll have to spit the right word out in a minute. And there's one here, one there, and the 5th one is over the middle up there. And you can see the thermostats on the walls where, you know, that one's kind of right over there. This one right here, and they're portable. Now you can hardwire them, so that's good. So that's that option. Now the reason for these guys is AC. Now they're running right now just to keep it adjusted, fine-tuned, I guess we'll call it. You really don't need them, but it's nice to be able to adjust that last couple degrees very quickly. Now the thermostat for the floor heat is right over here. Again, we're still working on this building, but that is the floor heat. And now there's different ways to put the thermostats in a concrete radiant floor system. One of the ways is to place a piece of copper down the floor and put the thermostat down it. I hear that's a really good way of doing it, but that's not the way we did it here. We just use these standard thermostats. And there's one here in this hallway, and that controls these 3 rooms over here, which there's 3 rooms here that can be divided or opened up with those tracks, portable wall. And then the 2 restrooms are on that thermostat, and they are here and here. The 3rd zone is the kitchen, and it's right on the other side of that wall. It's just a small one. I'll show you it in just a second. Now, I'll show you where it comes from, and it is right here. This is the manifold for the kitchen. It just has 2 loops in it, and most of one of these loops here is in the hallway. So we just wanted to be able to run that a little cooler. If there was a dinner going on or something, and a kitchen typically gets hot, we wanted to be able to run it cooler than everywhere else, nobody else freezing, and them not melting in there because of the appliances making heat. So these circuits here each go out, and they're 300 feet long, just like the ones in the shop at the mill there. And they go down in the floor and come back. They'll go down in, let me think. Yeah, they'll go down this one, come back up this one. This is the hot side, and this is the return. So water will go in, go down each one of these lines, come back up this one. And you can adjust the flow with these fellas here if you need to get it all dialed in. These are little flow meters, so they'll move up and down as that system is rolling, and that's kind of how that works. Now, let me get to the meat and potatoes of this outfit. This is a Norritz boiler for radiant heat floors, and it really does a good job. Right there's the model number right there. It's was at 199,000 BTU. Really does a good job. And again, it's maintaining the heat in this end of the building. Now the walls are very thick. They're a foot thick insulation, foot thick in the ceiling and walls. And now the floor has no insulation under it. It's just because the way the building was made, there's an exposed outside lip, and really like how that's made, but it doesn't, not going to benefit by insulating. We're going to lose a lot anyway. So I'm going to try to back up here and let you look at the overall system here. Now this, I was showing you the tank at the mill up there at that shop, and it feeds out of the bottom, and it is incorrect. This is what you want right here. It needs to feed out the top. There's also this Norritz system. Let me back up to it just one second. You can see here it's running water through it at 110 degrees Fahrenheit, and it'll also do domestic hot water. That's, see these lines over here, that is the domestic hot water out. So it runs over here and feeds our domestic manifold here. So this will feed all the hot side domestic, and this is all cold domestic water over here. So this is kind of a 2-in-1 system, and you can hear it running just barely. It's a really quiet outfit, and it has a little pump inside that will keep it to doing what it needs to do, I guess we'll say. It has a little piece here. A lot of this stuff, it's in the detailed drawings of pages seem endless in the book how to plumb all this, but if you pay attention to pick one style you want and pay attention to every one of the little details in it, it works pretty good. Now, these were check valves that are in that drawing. We didn't put them in at first, but they are necessary. So for all this to work right, they are a necessary thing. Let me move this off of here, and that way we can kind of see this better. But we have one here for the this one, and this one I think is doing the main floor on this side. Oh, here we go. I got it right up here on top. So this is doing the main other side of the building. That is the 50 by 50 right there. This is the classroom and hall room setups over here, and this does that little 2 loop manifold for the kitchen. So they're multi-speed pumps. They're 3-speed pumps. You can select whichever speed you want in them. Really slick. Here is a gauge and a Schrader valve for anytime you need to work on the system. You want to test for leaks before you charge it full of water. You can charge it with air, make sure it's not leaking. And this system runs 100% water. It has 0 antifreeze in it, unlike the one at the mill that's 100% antifreeze and no water. Now, the reason we're doing that is the antifreeze is ridiculously expensive, and it just wasn't necessary here. People in here constantly, you know, there's seldom a day or two span that there isn't somebody here. And we have a backup with the heat pumps outside. Now, I'm going off memory here, and I would really be surprised if there's $6,000 or $7,000 in doing this system. We just did the math on the floor pecs, and it's right at $1,000 to do this, and this is a 5,000 square foot building. So right there at about $1,000 to put that in. These manifolds, I'm thinking they're not terribly expensive, a few $100. I'm going off memory. I encourage you to just look these things up and get, again, current pricing as well. But and these little pumps, they're not really expensive. That guy there's not bad. There's, you know, these little, this is a very interesting little vent. It has lots of little pieces of wire wrapped up in it, and it automatically vents out any air that gets in it. And it needs to be right under this guy, and the water feeds right in above it. So a lot of that stuff is just, it's got to be that way, but it's really simple to do, and it's not terribly expensive. And then this is the water that comes in from the city water, and we put a shut off here because once you get it right, you shouldn't really have to adjust it much. There is a pressure relief valve, a check valve to keep anything from the system from going back, another shut off valve in case any of this stuff here needs worked on. We try to put plenty of valves in it for service purposes. And then this just is an expansion tank to make sure everything's where it needs to be. And again, none of these parts are terribly expensive, and this does the bulk of the heating. And I guess I get back to the main thing of why we're running water. The reason we're running water in this is we have the people in and out all the time if there's a problem, and there's, again, that backup of heat here being a heat pump. Now, the heat pump is not going to make it comfortable in here, but the heat pump, if it's 2 degrees outside, will at least keep it from freezing in here, and that's what we want. Keep it from freezing while we figure out what happened and get it fixed. So that gave us that level of comfort that we need to not spend all the money on the antifreeze and then have a system that's tricky to pressurize, tricky to do a lot of other things too, because it just seems to work really, really well. And again, we do this for the majority of the bulk of the heating, and then those the AC will kind of adjust it, fine tune it to make it really super comfortable. If it gets a little warm in there, for a lot of people, it'll just kick a little air on and drop that a couple degrees, make it really comfortable. So, and we're going to do the same thing on this side. Now, numbers on that. We just ordered the one for this side. It has 6 heads on it, and it was $90-some $100 for the outside units, all the line sets, and the cassettes that go inside that you saw in there. Now, the cool thing is there is absolutely no ductwork in it, and that was very important for this side of the building because we're out of height. We wanted that ceiling over there to be as tall as we could get it. This is a 12-foot eave height on this construction, and we wanted as much of that as we could get, and we're really close to using all of it. It's just a few inches up there, and from that unit there and that unit, they run down to a splitter and into another splitter, and there's like a controller, and it's all mounted above, kind of right above where that Christmas tree is, and it then sends 2 line sets out, a high and a low, to the outside unit. So there's 0 ductwork in this building. These are complete units in and of themselves. They have all the I think it's an evaporator in here, condensers outside, and they have a fan in there. They're really slick little units. For again, installation, it doesn't take special people to put these in, is another interesting part of it. Being, we were able to put these things in. It wasn't very complicated. Follow directions. Now, it would be nice to have the joints soldered. These were bolt together. They have compression fittings. Most of them leaked. So we have a guy that does our HVAC work here. He was here for two different times for very little bit of time. He got it all to where it wasn't leak, came back the next day to make sure it was all still sealed, and then charged it. So he fixed all those that were leaking, charged it with nitrogen, left it for a day or two, then came back when it was made and verified that it didn't have any leaks in it, then charged it with refrigerant, and he was out. And we're talking, I think it was like $1,000 for him to come and do all that work and do the refrigerant and inspect it all to make sure it was what it needed to be and sign off on it. And then we had this side here was $80-some because it didn't have as many heads. This only has 5 for heating half this building. We got a quote to do typical old school style HVAC with ducts and all that stuff, and an outside unit and little registers all in the building, and the ceiling was going to have to come down to right at the tops of the windows to allow enough room for the ducts to go through there, and it was $25,000. So here we are in this for less than 10, and is ready to go for less than 10, including the labor of him coming and doing it. And the other side, we're going to be right in that 10 neighborhood over there, maybe just a tick over. So we're going to have all of it done for right at $20,000. And we couldn't get one side done for 25 doing traditional heat and AC. And that's just heat pump with no heat grid in it, because we're, doing our majority of our bulk heating with this system here. So anyway, I hope that explains it. And that's something you could do later if you're doing a building or shop. You can put the AC in it later, do half at a time, maybe do another half later, and not have, $50,000 worth of traditional HVAC work done in there to get it all at one lick. You can, do 20, end up having 20 in it all together. And then this right here, again, I'll have to look, but I would really, really be surprised if it was over $6,000 or $7,000 for all the stuff here. It is really, really cost-effective way to heat a building. And then we just have an LP tank out back. I think it's a 2,000-gallon LP tank's what they dropped off, but we wanted enough to get through the winter, not have to constantly be filling it up. So anyway, hope that's helpful. Another amazing thing I forgot to mention is at the school meal there, at the shop there where the meal is, and that's probably the first place I've ever spent the day in the cold winter and not fought cold feet. I have terrible time keeping my feet warm. I don't have a problem keeping my feet warm in that shop, because it's what my boots are on all day long is warm, and I just don't fight with it there, and it's absolutely amazing. If you have to get down under it, work on something, the floor is nice and warm, it's not cold. An air hose or a extension cord, you pick up a big heavy 10 gauge extension cord, and it's still nice and flexible, because it's super flexible because it's laying on that warm floor. So I really love that aspect. Another thing too I failed to mention is you can usually run a room 2 or 3 degrees cooler than you normally would, because your feet are warm. It seems like you're spending all this time and energy trying to get warm because your feet are cold, where if you can, with this radiant floor heat, your feet are warm, and you're not trying to fight that to get, you're not sweating everywhere else trying to get those feet warm, because they're what's conducting that heat right through the floor. And I tell you, I really, really like it. A friend of mine, I was hesitant when I first heard about it, but a friend of mine who I trust, he said, "Man, you really got to try this stuff," and we did, and I really am glad we did. It is really amazing heat, and really excited about. But anyway, I just wanted to let you check that out. And another thing, this thing is a really high efficiency unit, so you can vent it with plastic PVC pipe, which is a very awesome thing. It's not all of the heat that thing builds is being used, so it's not wasting any energy. The air coming out of that is cold enough to flow through the exhaust is cold enough to flow through a plastic pipe, so that's pretty amazing too. Now the downside is to all that is there's a lot of electronics inside there. It's not super simple. The setup at the school that runs the big water heater, which again, I'm not saying that's a great system as far as that water heater. I think I'm going to change it out to one of these. Because it seems to just fight all that. It works hard all the time to get it to when it's super cold outside, to keep it where it needs to be. But it is simple. It's very, very simple. Of course it loses a lot of heat through the metal pipe it has. It's double wall pipe or triple. I think it's double wall. Anyway, and lose a lot of heat, but it's very, very simple. There's no computers in that system there at all. This one does have a circuit board in it, and then there's some computery stuff in there, so however you feel about those things. But anyway, that's that, and I'll just kind of pan across here and let you check it out one more quick time.